Hi students and future doctors. Welcome to the next class. So already we discussed electric field due to infinite plane sheet as application of Gauss law. In this class we will see electric field due to conducting sphere or spherical shell. So whenever we are taking spherical shell or conducting sphere of radius r, what is conducting sphere means? If we are giving some amount of charges for this sphere or spherical shell, they won't be available within the sphere. Always they will reside on the lesser surface area. Therefore, they will be residing on surface of that cylinder or shell whenever you are going to give some amount of charges. Now, how much charge is going to be stored on the surface? That one only we will give sigma is equal to Q by surface area. What is surface area? 4 pi r square. Now, total charge available on this surface sigma into 4 pi r square. Always it is going to acquire lesser surface area. So, what does it mean? Means if we are taking an object or conductor in triangle shape, if we have given some amount of charges here, 3 charges if we give, so they will acquire where the lesser surface area here. It is going to be moving to lesser surface area portion. If you give more charges, again it will go here. If you give more charges, it will go here. So like this cone, if we are taking cone, where it is going to be residing? If we have given charges, lesser surface area. Here it is going to be less. Later here, later here. So like that it is going to be moving. Charge takes always which is having lesser surface area resides. So Q is equal to sigma into 4 pi r square. Now what is the electric field produced by this conducting sphere at some distance? Totally we will be having 3 points on this. One is outside, one is on side, on the surface, another one is inside. So first we will take outside. So whenever we are taking outside, from center to this point P is at a distance smaller. Now to find electric flux here, you have to close this surface. Whenever you are closing the surface, so we are going to get smaller surface area we are assuming. In derivation we will derive all this, then cap we will take. So how the electric field intensity for positive charge means always it will be away. So according to Gauss law, so E bar dot ds bar is equal to Q by epsilon naught. So E ds cos 0 because both n cap and E will be in same direction is equal to Q by epsilon naught. So E, what is integral ds means? Yes, Q by epsilon. Now here it is going to be very important. So actual derivation is not required for us for solving the problems, but you should come to know sometimes how this equation we have taken, therefore we are deriving. So E. So what is the surface area? What is this S we have taken means? What is this ds? ds is nothing but surface area of Gaussian surface. This surface is Gaussian surface because we are going to close the object. So charge enclosed by the surface. That surface is nothing but Gaussian surface. So what is the surface area of Gaussian surface means? It is having radius smaller. Therefore, 4 pi r square. What is Q already we got here means? This is nothing but sigma into 4 pi r square. You can leave it as Q also, no problem. So 4 pi got cancelled means E is equal to sigma by epsilon naught capital R by small r whole square. This is one of the important equations. If you write as it is like this without writing surface area, so E into what is smallest we said? Surface area of the Gaussian surface equal to Q by epsilon naught. E is equal to Q by 4 pi epsilon naught r square. This one also KQ by r square. We can remember like similar question, similar equation If point charge at some distance r, what is the electric field intensity? Kq by r square. This is also going to be same. But you have to remember carefully, Q is equal to sigma into 4 pi r. That's one you should remember. Okay, this is the main formula. Sigma by epsilon naught capital R by small r whole square. Correct? So E outside is equal to sigma by epsilon naught capital R by small r whole square or kq by small r square. What is small r here? Distance from center to the point where we have taken. Next step. If you are taking on the surface, now point is going to be here. So electric field on the surface, isn't it? Otherwise, electric field on surface. So now see, small r and capital R are equal. Now write from this equation. You need to derive again, once again, you no need to derive. Sigma by epsilon naught, capital R by capital R whole square. Therefore, answer will be sigma by epsilon naught. Or if you follow this equation, kq by capital R square or small r square. Isn't it? Now, within the surface, if you go, within the surface, if you are going, this is point P, this is R. R is radius. But what we said inside, if you want to draw Gaussian surface, there is no charge inside this. Therefore, E inside, if you are taking according to Gauss law, Q by epsilon naught, according to this formula, E bar dot ds bar is equal to Q by epsilon. But there is no Q inside. Therefore, inside electric field is zero. Inside the conductor, so electric field intensity will be zero. So this is main points. These are the main points. So outside means sigma by epsilon naught capital R by small r whole square. On the surface means sigma by epsilon naught. Within the conductor means electric field intensity will be zero. Now how they will ask question on this? They will give in a conductor, without knowing to you, they will give in a conductor of radius, spherical conductor of radius 10 centimeters. So electric field intensity at 20 centimeters from center of the sphere is going to be 100 Newton per coulomb. So what is the electric field intensity at 5 centimeters? They will ask. So what you people will do means E is directly proportional to, or E is equal to kq by r square outside. Therefore E1 by E2 is equal to r2 square by r1 square. So many students will do. So, but this is wrong. Why it is wrong means, so we are going to forget one point in this. This 5 centimeters where it will be coming means 5 centimeters will be coming inside. So inside the conductor, what will be electric field intensity means 0. Means from center to near the surface, electric field intensity is going to be 0. Means radius is 10 centimeters means at 1 centimeter, at center, at 2 centimeters, at 9 centimeters, it is going to be 0. Okay. So like this, they are going to ask the questions. And they will give one graph from this. Very, very important graph. So what is that graph means? If it is a conductor, so from center to surface, so what will be electric field intensity we said? Inside it is going to be 0. Outside if you are going, E outside is inversely proportional to R square according to formula. On the surface, sigma by epsilon naught, it is going to become maximum. So if you want to draw the graph, how it is going to come means like this. So center to surface, it is going to be small r is equal to capital R. So what is from center to surface means, this is the graph drawn between electric field intensity and distance. So electric field intensity will be 0 from center to surface. Therefore line will be coming here. So after that suddenly at r equal to r, so E value is going to be sigma by epsilon naught on the surface. Whenever r is going to be r, it is surface. later it is going to decrease, rectangular hyperbola. So we discussed already in graphs. What is the nature of the graphs if it is inversely proportional? So graph nature will be coming like this. E and R in case of conducting sphere. So it will be coming like this. So this is 0. Later it is going to be maximum. So outside it is inversely proportional to R square. Okay. Now this is about spherical shell or spherical conductor. Now in next class we will discuss if it is non-conducting spherical shell or non-conducting sphere. If it is non-conducting sphere, how we have to do this electric field intensity. For that, again another formula will be coming. You should remember carefully. So in this class, because of conducting sphere, what is the electric field intensity outside? What is the electric field intensity on the surface? What is the electric field intensity within the metal surface we discussed. Okay, so you should remember mainly these formulas. These three formulas, if you remember, you can solve almost all the problems on the spherical conducting or spherical conductor or spherical shell. Okay, so we'll meet in next class.